I'm hoping by this point you're just watching this to check your answers and you're able to ace this one by yourself, because again, it's the exact same as part C, part D, and part F. Just the only thing that's changing is this amount of milliliters of NaOH. So again, first thing I'm going to think about is I have 0.0800 liters times 0.50 moles per liter. Excuse me. 0.040 moles of NaOH. So again, starting right off with my Henderson-Hasselbalch, I know the pH is going to equal the negative log, one too many O's. Well, let's just go ahead and write pH is going to equal pKa, so I don't have to write that. Plus the log of my conjugate base value is going to be equal to that NaOH, 0.040. Well, again, I'm always starting with 0.05 moles of acid, but if I react 0.04, that leaves me with 0.010. At this point, we're almost out of acid. We've almost titrated this. The acid in the buffer is almost completely gone. But because it is still so much stronger as an acid, this conjugate base pair, than as a base, the pH is still going to be acidic at this point. And we see for G, the pH turns out to be 3.95. It's starting to climb, but now we have another data point, 80 milliliters, 3.95. Looking at the ice table for this same problem, I'm going to have OH minus ions plus HNO2, and they're going to make a water plus an NO2 minus ion. We just calculated on Lack's page, we're going to have 0.040 moles of him, just like every other time, 0.050 moles of this guy. Water's not going to matter, and we're not going to have any NO2. But all these are still going to react. It's getting close to where we're running out of OHs, but they're all going to go away. 0.040 moles are going to react, which means 0.040 moles of him are going to react, which means 0.040 moles of him are going to be created. So I end up with 0.040. That should not, well, I guess an undo would make more sense. 0.040. I'm going to end up with 0.010 and none. So I've got my acid and my base and the values that they represent. Now I undid that decimal. So I can use the Henderson-Hasselbalch equation. pH equals pKa plus the log of my base, 0.040, over my acid, 0.010. And just like we did in the first part of this slide, that pH is going to turn out to equal 3.95.